breathing easily is something many of us just take for granted. But anyone who suffers from asthma, like my brother, knows this can change quickly. Millions of people have to manage their asthma, and that is something chemists can help with. This is Real Chem. Inhalers contain a fixed concentration of an active ingredient that is aerosolized to help them breathe. If the concentration is off, the relaxation effect on the trachea is lost. What do we mean by a fixed concentration? Vamos a mirar juntos. Let's explore. Chemists often use the term molarity to describe concentration. Molarity is defined as the number of moles of a solute per volume. In other words, the number of particles in a given volume. Imagine you're given a solution that has a fixed concentration. That is, a fixed number of moles of a compound in 1 liter of water. Here we can use X to represent 1 mole of the compound. This is analogous to knowing drug concentration, or rather the exact concentration of the active ingredient in a medication. In some asthma medications, the concentration of the active ingredient is fixed within a certain range in order to relax the trachea, which then allows the patient to breathe. Outside of this range, the trachea will not relax. If we zoom in, we can see what is happening in this solution. Here, we imagine that we are zooming in the trachea and seeing a fixed amount of the medication coating the trachea to allow dilation. Now, if I were to remove half the volume of water from my solution, I will still have the same number of moles of compound in the total volume. But now, when I look at the same area, I see more particles. I have made this solution concentrated. I'm adding more of an active ingredient in the medication to the trachea. The concentration is not in the required range, and the trachea will not relax. Now, instead of removing half the volume of water, I instead double the volume of water to the original container. In this case, when I zoom in, I will see that there are less particles. In fact, there should be half the number of particles. We have effectively done a dilution. I'm adding less of the active ingredient in the medication to the trachea. There will be no reaction occurring, and the trachea will not relax. But what if instead of water, I decided to add another solution to my first solution? I will show the moles of the second compound as Y, and I will keep the volume of the second solution the same as the solution above. What will happen? In this case, even though my total volume of solution increases, the number of moles of X remains the same as in the first solution, and the number of moles of Y remains the same as in the second solution. I have effectively diluted both solutions. In our asthma medication analogy, we consider the fact that most medications are not pure solutions of the active ingredient. There are other compounds in there, but these other particles will not change the concentration of the active ingredient in the drug. Adding any other solution that does not contain the active ingredient will only dilute the active ingredient. Again, in such a scenario, the trachea will once again not become relaxed because we have not met the required concentration. Concentration, like molarity, is essential as it provides a quantitative measure, allowing us all to control the amount of a compound in a given solution and predict reactions accurately. Understanding these principles will allow you, my brother, and billions of other people to breathe a little more easily. Vamos a explorar. Y no se te olvida tener fun.